deal with miracles cannot provide for us. Second principle. Hope that's in focus. Scientific observations are repeatable. This arguably is more a corollary of the uniformitarianism principle than a distinct first principle, because it follows that if natural law acts the same way at all times and in all places, that I or anyone else can repeat the experiment. When I submit a paper to a scientific journal for publication, it always has a materials and methods section that describes exactly what I did to get that particular result. If it doesn't have a materials and methods section, it would be immediately rejected. In contrast, one never sees a materials and methods section in a religious tract. It just doesn't work that way. Third principle. Scientific theories must be testable, and to be more explicit, they must be falsifiable. And this is the heart of the scientific method. I alluded to this a few moments ago, and this is perhaps the central tenet of the scientific method. Popper's so-called line of demarcation between science and non-science, between science and religion. Implicit in this is that a scientific theory must be tested, or excuse me, must be stated, in addition to being tested, it must be stated with sufficient clarity, precision, detail, and internal consistency that one can deduce singular, unequivocal predictions from the theory that are testable against the empirical evidence. The book of Genesis suffers badly in this regard. Fourth principle. There's a web of interconnectedness and internal consistency. Theories in all branches of science must be consistent with all the theories and empirical evidence in all other sciences. Thus, the theory of evolution by natural selection must be consistent with genetics and cell biology, but also with geology and physical chemistry and so on. If this isn't true, there's something wrong with one of the theories or some of the data. So a really interesting example of this involves the history of Darwin's theory itself, which, although somewhat initially successful, that is Darwin's theory, the publication of the joint Darwin-Wallace papers in 1858 and the publication of The Origin of Species in 1859, Darwin was essentially dead by the year 1900, so proclaimed by Alfred Wallace himself. Why was it dead? Because it was inconsistent with a widely accepted theory of the age of the Earth and an incorrect theory of inheritance based on the notion of blending inheritance. The theory of the Earth's age was promulgated by Lord Kelvin, Kelvin of the temperature scale, one of the most prominent physicists of his era, had actually miscalculated the age of the Earth based on its rate of heat loss, giving Darwin only 24 million years for evolution, which even Darwin thought inadequate. It turned out that the physicists based their calculations on an incorrect theory, and that Darwin was right when he wrote in a letter late in his life that he somehow sensed the age of the Earth was greater than Kelvin had allowed. Kelvin made his calculations very shortly before actually, the discovery of radioactivity, and the vast store of energy in the nuclei of atoms had not been taken into account in his calculations. The problem of blending inheritance, which Kent alluded to also, is the problem, not the blending inheritance itself, is that selection operates on genetic variation, and it certainly does. But as sexual reproduction blends away variation, as Kent suggested, there would be nothing for selection to operate on, and this indeed would be a problem because Darwin's theory requires that genetic variation exist in populations, and it comes into existence in population. But this was a falsification, as it were, of Darwin's theory towards the latter part of the 19th century. And Mendel's theory, which was rediscovered in the year 1900, provided a sound genetic foundation upon which a theory of natural selection could operate, and actually led to the rebirth of Darwinism, which is being so intensely battled by creationists today. Final point is that scientists are reductionists. That is, all natural phenomena can be explained in simpler terms. And I would say that scientists are incorrigible reductionists. This may not exactly be a first principle of science, but it's certainly part of the sociology of science, the culture of science. Biologists have insisted for a long time that the whole of life, meaning essentially the activities of cells, could be understood in terms of chemistry. And this has been dramatically confirmed in the past half century or so, and particularly in the past 2 decades with the extraordinary progress that has been made in cell biology, which is now pretty much called molecular cell biology. So life, as we understand it, is reducible. I now want to just take a few minutes to briefly walk through the major classes of evidence, much as Kent did, that bear on the origins of species, the diversity of life in all of its complexity and all of its seeming adaptedness. On the one hand, and I want to look at neo-Darwinism, the theory of evolution, in contrast to creationist theory, in context of these metaphysical principles. On the one hand, we have neo-Darwinism that claims that the whole of the diversity of life evolved from a single or from a few initial forms, primarily by a process of natural selection operating on genetic variation, as characterized by the principles of modern genetics. On the other hand, we have the particular theory of creationism advocated by Kent Hovind, and it's not the only theory of creationism. It is perhaps the most extreme position. It's based on literal interpretation of the Bible, and especially the book of Genesis. And what I want to do is to look on a rather coarsely focused level at how these different classes of data bear on the alternative theories in context of the metaphysics of science. And I point out before I do this that if you are not doing your analysis in context of the metaphysics, the first principles that I set forth, and these are not my principles, I simply read a bit in the philosophy of science and extract these from what I think is the current thinking about the philosophy of science. If you do not do your analysis in this context, you're not doing science, you're doing something else. This is where the line of demarcation is between science and religion. It's not between microevolution and macroevolution. Let me say first that it's difficult to derive predictions from the